Hello everyone, welcome to my trial lecture. My name is DiWu. I'm working in the Department of ICT and Natural Science, as well as the Department of Computer Science in NTNU. My main supervisor is Dr. Hao Wang. Today, in my trial lecture, I'm going to talk about the topic about public sector digitization, risk analysis, and risk modeling. In this lecture, I'm going to explain several subjects, including the introductions about the background of this topic and main challenges. And also, I'm going to introduce model-based risk analysis methods and data-driven risk analysis methods. In both methods, I'm going to talk about how to model the risks and also how to what is the process of how to build the risk models. At the end, I'm going to conclude for my own experience. First, let's begin with the introduction. From 1960s, we are facing the great challenges from the urbanization process. According to the numbers from the United Nations, in 2019, we have arrived, the population who lived in the cities has already reached to 56%, and is projected to be more than 66% in 2050. So in that, from that context, this becomes an overwhelming phenomena all over the world. So this rapid growth has challenged our city life. It changed our lifestyles and also brings a lot of new problems to our infrastructures and also in the public sectors. The public sectors are all related with us. The public sector, especially in the cities, and they provide the basic services to people with all respect, including like security and health, for instance, our pandemic situation, basic educations, law, also economy activities, and most importantly, it provides the resources as the infrastructure to operate our daily city life. The infrastructures including the communications, for instance, transportation, energy, and water and resources, and so many different services. And in addition, those services can be classified as information publication. Most people, they want to know what happened with those services, and also the process management. If you want to ask for some services, how does it processed? And most importantly is about risk control. Our infrastructures, most of them in the cities are pretty old. So how to meet the new requirements from people to higher quality public services is also a big challenge in the public sectors. Fortunately, we got the help from digitization process. With the development of digitization process, we have got new tools to improve our public service. The digitization is also challenged from different perspectives. First is that we want the digitization to provide more complex service. For instance, we want the service to be a fast response, and we want the service, and we just send one requirement, but those services are related with different public sectors. And also the digitization process has the challenges on the technical perspective as well. For instance, the sensors, now we are using a lot of sensors all around us, but the sensors qualities, where to deploy them, is also a technical issue. And also the other is that the digitization can help us to process all of those data, but the processing also require high quality, for instance, servers or cloud and so on. And also the other issue in the digitization process is about evaluation. When we deploy a prediction or when we are published a result, how to evaluate the results. As well as the digitization process in the public sectors is also has to be highly related with administration reform. Because now with more people are living in the cities, and the administrative process, it needs to be more dynamic and needs to provide higher quality services. So which brings higher requirements over the digitization in the public sectors. So that comes with the smart city governance. The smart city concept is well established from the 1990s. And so now many countries and many cities all around us have implemented many ideas about smart city. Now in many countries, with one ID number, you can get access to many public services, including transportation, including also communication services, and also law, education, and everything. This brings a lot of convenience for our daily life in the cities. However, is that all? Do we have other new requirements? Do we ask them for better service? This is true. And so one of the important challenges is coming from the risk control in the city management. The risk is a well accepted concept. However, in the public sector, how to evaluate and what is a real risk is still a blur. So generally, a risk is a very abstract concept. We can define it to that a risk is to deal with the possibility that an event or situation with the undesirable consequences for some subjects may happen. So the consequences are often seen in relation to some references values, and the focus is typically on the negative consequences. When something is good, most of the time we don't take it as a risk. We concentrate on the risk which might have some bad consequences to our city life. So the risk in public sectors are two categories. There are emergencies. Emergencies are more related with events. For instance, a pandemic happens or some accident happens. But another important risk in the public sectors is related with the infrastructure maintenance. Our infrastructure, what's their performance, what's their status, can they provide efficient information, are they maintaining in the right order? And so those are information we need to know, and it's highly related to our daily life. And also, so we have understand that in the public sectors, it needs to provide many different basic services. And also with the digitization, it can be a tool that will help us to improve the services. And one of the important services in the public sector that we can use from those tools are risk control, especially for infrastructure maintenance. So later, I'm going to introduce two different types of methods that can help to improve the services, especially related with the infrastructure maintenance. So those two methods categories are model-based methods and data-driven methods. There are some questions and challenges in this subject. With the rapid growth of the urbanization, more people start to enjoy the city life. And one of the important reasons is that the city can provide us better services. And in order to implement and improve those services, we can, especially with risks, there are several questions and challenges. So for the challenges with respect to the risk, there are several ones. Risk assessment framework. For instance, how do we evaluate the risk, and how do they connect it with the data, and how do people realize, how do they identify the risks? And also the other is how do we model the risk? How do we represent the risk? How do we describe the risk? The other is risk prediction based on our experience or knowledge. What could be the risk in the future? And with respect to the application domains, in this lecture, we are going to introduce 3 basic domains, including transportation systems, which are most important in the cities, and also power grid system, the energy supply, and also water supply systems. Let's begin with the model-based risk analysis. The risk is always a big concern in our daily lives, in our industrial process, and every day. So the risk research is also attract many scientists. Scientists are trying to make the risk more quantitative. So as this traditional or subject for risk analysis, there are many types of quantitative risk analysis methods have been developed. The most famous one or most used one is probabilistic risk assessment methods. It's named PRA. There are 3 questions in the PRA which are important for the quantitative evaluation. First is, what can go wrong with the studied technological entity, or what are the initiators or initiating events that can lead to adverse consequences? So to identify what are the factors of the risk. This is the first step. And the second question is, what and how severe are the potential detriments or the adverse consequences that are the technological entity may be eventually subjected to as a result of the occurrence of the initiator. So how severe of this event, or how severe is that factor change can be with respect to the risk. So the third question related with the risk analysis is how likely this factor or this event is going to happen. So how likely to occur are these undesirable consequences, or what are their probability of their or their frequencies. So this is modeling. This is a famous or well-accepted risk model, which consists of 4 different parameters. For instance, SI, it represents the sequence of events of the of n accident scenarios. And FI, it represents, so SI is the different scenario, different categories of the accident. So FI, it's represents the frequencies of the occurrence of such sequence of events. So how frequent is going to happen? And CI is the consequences that would result if that scenario were to occur. So if that event happened, how serious it is. You can model this as different levels. It depends on the domain knowledge. And PI is a joint probability density function that's describing these uncertainties. So basically, the risk is related with a series of accidents and the uncertainties, and also the consequences evaluations. Now the risk definition has been extended. For instance, there are several papers also mentioned that the risk evaluation is also related with the domain knowledge. So sometimes the definition of risk can also add another parameter, which is K as the knowledge. And also, as a matter of fact, with the development, that the probability concept can also be extended, because in this part we use the probability to describe the uncertainties of the risk event or the factors. In that case, the uncertainties, after we can also use other techniques or methods to describe, for instance, the fuzzy. It also describes the uncertainties, and also most recently people use evidence reasoning and also to describe the uncertainties. From the model-based risk modeling process, usually the process is like this. First, the risk is defined. What type of parameters, factors, indicators do we use to define the risk? And the second is about the quantitative indices selection. So to describe those risks, what kind of parameters or what kind of index should we use? And then we define a computation formula to make those to calculate those indices, and then we can see these risk indices are changing during the evolution process. And then normally in the model-based risk analysis process, it's based on the simulation system. So they are accidents, so they define different scenarios related with those accidents, and then they will try to use try to calculate and by those indexes and to see the output of how the response of the system. And normally it will involve a risk curve and with associated uncertainties. Now we introduce several applications related with the risk analysis in the public sectors. First is the public transportation system. This is a paper in 2020, and they defined a transportation network performance risk evaluation. So they have classified they defined the risk in 3 different categories, including the reliability of the public transportation network, and vulnerability, and the resilience. So the reliability in the transportation network is the probability of network to remain satisfactory under perturbations. So with some accident happened, whether it's probable to remain working. Vulnerability is the susceptibility that of the network to the perturbations. So it's in extreme cases and whether the network can still work. And the resilience is the transportation network that can resist, absorb, adapt, and how much time or how efficient it can recover from the accident, from perturbations. After the risk is divided into reliability, vulnerability, and resilience, and this paper also further divided those indices into small or into detailed indices with respect to the risk in the transportation network. For instance, reliability, it's further divided into connectivity reliability, travel time reliability, and capacity reliability. Connectivity reliability, they used whether between an origin and destination node, how probable that they will remain connected during the predefined travel time. And the travel time reliability is from the traveler's perspective, how much time they are going to spend after the perturbation. And under a certain kind of service level, how much do they spend really? And so to define the probability between this ratio. And the capacity reliability, they define it from the whole transportation network perspective. So in their extreme cases, and how the transportation network is reliable. For instance, there are like 60 different different levels of nodes are blocked. In that case, whether the transportation is still reliable. And the vulnerability is talking about they further divided into 2 different indices, including the closeness and the efficiency. The closeness, it defines as in the transportation network, and how much that between the average distance between the all nodes, and when it's closer, this average distance, and which means that the change when the perturbation is happening, the change cost is very low. And so actually they use this to describe the vulnerability of this network. The efficiency, they are taking the reciprocal indices to describe this vulnerability. And also they further define the resilience in the transportation network. This describe when some perturbation is happening, how much time and how much energy is going to cost for the transportation network is recovered. So these describe the how robust this network is. So in this paper, after they have set up a simulation system and defined several different types of scenarios, and to evaluate evaluate the performance of the current transportation network. For instance, this is their results of their simulation. So there are network performance in the dark black line, and also the required service level is on the green line, and also for instance, the resilience when some accident happened, and then how much time and how much energy that the transportation network needs to recover. So they have defined four different types of scenarios in order to test and evaluate the transportation network for their risk evaluations. Their risk has been further divided into reliability, vulnerability, and resilience. Actually, the same can be transferred to the public smart grid. So for the energy supply system, they are also work to evaluate the risk in the public smart grid with those indices. For instance, this paper in 2021, and they are mainly focused to review the energy system resilience. So, but they also talk about, for instance, the reliability of the power grid and the robustness. So, and also the recover capacity, and by different in the smart energy supply network. So, how robust or how reliable, how resilient this network is. So in this paper, because it's a review paper, they also try to classify different types of threats that in the energy supply network. For instance, for physical level in the energy system, that the different sources of the energy providers can have issues. And also the threats will happen from the duration disturbance, and also they have defined the severity of different accident when it happens, and how risky it is. So so this means that the risk analysis, the model-based risk analysis from the transportation network in the public sectors, and also with energy provider network, they are using similar ideas which are based on model to evaluate the risk. And this means that the risk analysis can be further divided into different indices. And then what you need to do is that to calculate, or to based on the knowledge or the historical experience, in order to identify that from the reliability index, the resilient index, or the vulnerability index. This is the same idea in the public water supply systems. And for instance, this is from 2011 paper work, and it also defines the water supply system, the quantity of water, and how to evaluate the risk in the supply network. They also divided the risk into reliability, resilience, vulnerability, and standard deviation and maximum deficit. And also they have developed a new index named sustainability. So it's similar ideas. It's between the target of water supply and the real supplied water quantity, and whether they are reliable, and vulnerability, and how many times it happens that they are short of water. And resilience is when the shortage of water happens, how much the system can, how fast or efficient the system can respond. And so those are the basic ideas of model-based risk analysis, which there is a model that is written in first you define the risk, and second you develop a series of indices, and third you define a formula to calculate them, and then based on some scenario settings of the simulation, and then how much the system will change. In this water supply system, they have investigated the place, a water source named Rio Grande Basin, which is pretty big area in the south of United States, and they have checked. They have used their index system to evaluate that the system from these regions, and how strong or how risky is the water supply between all of those cities. And so they have also, in this paper, they defined some simulation scenario settings based on different water policies. And so to compare that between different policies and how those indices for the water supply will change. So it's a very interesting work that we can see from the model-based risk analysis. So we have introduced 3 applications from transportation network, from the water supply system, and national grid, or the energy supply system. And so we understand that to evaluate the risk, there are some model-based methods. And from those methods, we can realize the advantages of those methods is better understanding with the domain experts, because those models have been built by the domain expert. They have learned this way. And they provide better interpretabilities, which is that people understand what those factors means, and so it's easily to understand. And then it contains a lot of knowledge. So knowledge intensive, I'm not sure is advantage or disadvantage, because to build a convincing model to evaluate the risk, it needs a lot of domain knowledge. So this is also advantage for model-based methods. And then there are less requirements for the hardware. This is traditional knowledge, and those has happened. Those models are built without the data collection, without requirement of intensive data collection process. So there are less requirements from the hardware, and usually provide a better overview. For instance, if I want to evaluate the risk in the whole energy supply system, or for the whole water supply system, or for to evaluate the whole transportation networks. And so those are easily to be seen by the model-based methods. But there are also some disadvantages. First is that most of those methods, and they are based on simulation systems. So you have to define the scenarios by yourself, and you have to set up the parameters by yourself. So whether the result is really convincing, it's another issue. And so the other disadvantage for model-based methods in the risk analysis is that it has higher requirement from the domain knowledge. Okay, so knowledge intensive in the disadvantage perspective. And if you are not the domain expert, it's difficult for you to understand those models. I just selected some basic models with respect to the reliability, vulnerability, and resilience. But some detailed risk evaluations needs much more knowledge from the domain. And also these model-based methods, they are less efficient with respect to the real-time decision making because it's based on probabilities, and so it can provide you an overview for many years for a longer time span or on a bigger spatial place. However, for the real-time concrete risk evaluation and decision making and response, is difficult to do with it. And so next we are going to introduce the data-driven risk analysis, which is a different perspective, and we'll see what's the difference. Data can be another resources that we can use to improve our risk evaluation and modeling. And this issue has been greatly accepted by research, industrial, and also the management perspective. These advantages are all coming from the broadly used data technologies. So in order to improve the risk modeling from the data perspective, we have identified the process of how to do the risk evaluation from the several steps like this, from the data collection to data pre-processing, feature selection, risk modeling, prediction, risk prediction, and also at the end we can also output some decision support. And we can all realize that the ubiquitous sensors are all around us, and especially with infrastructures and public sectors, including, for instance, the intelligent transportation system, the energy providers, and also the public water supply system. We can all see that the technologies are helping us, and also they are helping us to avoid and model and evaluate the risk. For instance, this is a work more recently in 2021. Here we can see that the risk concept can be extended with respect to the intelligent transportation systems. And here they have defined a safety evaluation in order to see in the public service which road is more safe and what factors are they related with respect to the original idea in the risk about reliability, vulnerability, and resilience. We can also see directly from the data we collected from the road. Here they have taken two different types of sources. One is from the videos, that the very detailed trajectory data. The other is the detectors for accident and conflicts. So here they have used the traffic status data that are pre-processed from the trajectory data, and they also use the time to conflict index to calculate the conflict data. And after they have done classification and to see whether the conflicts are existing. So it's number yes. If it's a yes, and then it's an unsafe road, and if it's zero, and then it's a safe road. And their aim is to build a model as well, and in order to evaluate to see the safety and as well as the risk in the road. So they have used the logistic model. They use the video data to train this model, and they are using logistic model to identify the different factors, what's their relationship, and they use a machine learning method, for instance, SVM, random forest, to predict the safeness or the risk level in the road in order to make a better model. So this is their results in their paper, that they have identified the different index from those original data sets, including the volume on the road and the average speed, standardized speed, and how many trucks. And in this case, they have seen that there are some potential relationship between those type of index, and also they have compared the different models that they use in order to see that by different time to conflict threshold, and how much their model can be used. So this is a very interesting idea, that we have extended the original risk concept based on the data we can collect from the reality, and then we can identify new indices, for instance the volume or the average speed. We can calculate them in order to relate them with the safety and risk on the road. Another idea from the public smart grid for energy supply system, they're using the same index as resilience for the energy supply network. And here they developed Gaussian process regression model as the model to predict, to estimate the resilience. And so what they are using for data is that they have used the data as the baseline for to compare with the resilience estimator, and also they use the data to generate the failed nodes. And so in this case, that the generated failed nodes can be combined with their original estimator model and to give predicted results. And also by the real data, they can they can provide the baseline for the resilience. And so actually they can, at the end, they can compare the generated or model-based results and the real results. And in this paper in 2021, and their aim is to show that with the knowledge or without the knowledge about the estimator, what effect they are going to give. So we can see that in their results by the 5 minutes intervals, that if we have added some supplementary knowledge, that the estimator of resilience is going to be very low in the state error, in the relative error. So this is a very interesting idea as well, because from this we can see how we can use the data-driven methods. From the real data, it can provide the baseline, and in order to evaluate our original knowledge-based models. So this is another idea. And also this is our own work that is based on smart water supply, and is also trying to evaluate the risk in the water supply system. And in this case, we also collected different types of data from the water supply system, but here we focus on the water quality. And then in this case, we after pre-process the data, because the sensor data are not often with very good quality, and then we can generate a risk model for the water supply, but with respect to the quality in the system. And then this prediction can be used for further decision support. And here, this is the risk map that we have developed based on the data we collected from 4 different cities in Norway. And by this risk map, we can see that if we define the risk levels before they have identified the 3 different risk levels with respect to the water quality. However, after our study, we believe that the levels can be 5 is more reasonable for the water quality evaluation. So from this idea, we feel that the data-driven or the data can provide us further knowledge over the risk evaluation. Before, based on their knowledge from the domain expert, 3 levels are better. But however, based on our data-driven risk evaluation, we believe that maybe 5 is more reasonable. So here we can see that the data-driven technologies can also help to identify, evaluate, and help to find the risk in the public sectors. The advantage with the data-driven methods is that it's high-resolution risks. And because we can, based on the very good quality of the sensors, we can find the real-time data and to give a faster response and to the risks and compare to the probability. And the prediction accuracy is relatively higher than the knowledge-based. This has to be based on some assumptions, like the data quality you collected has to be high, and also the volume of the data needs to be high as well. And another advantage for the data-driven methods with respect to the risk is that sometimes it can bring us new knowledge for the risk. For instance, it can generate new index, and sometimes it can help us to evaluate our model as well. So, but the disadvantage of the data-driven risk methods is that it is difficult for the knowledge abstraction. This is also one of the problem we meet, because risk evaluation is normally interdisciplinary research. We need to collaborate with a domain expert, and so the results based on just data is difficult to be understood and difficult to be accepted by the domain expert. And the other disadvantage is that it has very high requirements over the hardware, from data collection, data processing, and evaluation. We need to store and process massive data, and in order to provide better or accurate risk in the future. And in order to conclude, or in this lecture, we have introduced the problem in the risk analysis and modeling in the public sectors. The challenges are from more complex requirements, limitations of the digital tools, and also with the complex decision-making support. And the methods, we have introduced the knowledge or model-based methods, and as well as how the data can help us to improve the risk analysis and modeling. For future directions, I think the research have a brand new direction, because this is still in the beginning stage for our public services. So what I can think of, for instance, the risk analysis framework, how can we build the framework, or how can we link them general risk and the data collected, and how to build the models between them, and how do we combine the model-based risk analysis and data-driven analysis, how them can work efficiently together to provide better services. And also, how do we integrate more domain knowledge in the risk evaluations? And also I've seen a lot of requirements from the decision-making support based on the risk analysis and modeling. So these can be considered comprehensively. So thank you very much to join my trial lecture.